So I have here just a little bit of a startup piece. I have a global constant for my generic array size, 30 elements. I have an array init function. Um, I create my array. I create my initial value, which is just a series of random numbers, nothing to kind of worry about as far as that goes. And I can come over here and say for int I 0, I less than array size. And this is just going to give me some random numbers. Oops. You know, it'd be really helpful is instead of I actually put the array value. Okay, one more time. This time without the oops. Okay, so you see the index, you see my values. Some of them go up, then they go way down, then they go back up, then they go down, and they're just kind of all over the place, kind of like you would expect with a series of random numbers, right? Okay, and we could have this as being, much larger if we needed to. There's nothing special about having 30 elements. We can have 300 elements. It's just we pick 30 to start with. Okay, so the question is, how do we get these in a sorted fashion? Now, with some things like in Python, your list, they have a sort function that's built into the list. And I can just say, hey, sort. And it goes and it tries to figure out best it can. Okay, here's what I think it means, what it needs. If it's a collection of numbers, that becomes easy. If it's just a series of strings, it's a little bit harder. If I have a complex data type, and that's a really important thing. We're actually going to look at that not next week, but in the following week. We're going to look at user-defined data types. We're going to do it under a couple weeks. We're going to talk about object-oriented programming with classes, and that's something that you define, you build your own, and then how do you determine what's bigger? You've got to define that, and that's the reason why it's not built into things like C++. Is C++ was designed for complex data, for doing system applications, for using complex data, not just arrays, not just integers and doubles and stuff like that, but where we can define our own data type. And so we need to know how we're going to do that. How we build our sorting feature is going to be directly related to what type of data we put in it. So let's look at how we're going to work with putting our data in. Okay, so if we come down here, there's a couple of different ways that we can do a sorting algorithm. Um, some of them are really easy to write. There's one out there that everyone seems to learn early on called a bubble sort. And you can go online, do a search for bubble sort, and find out how to do it. It's extremely easy to write. You're looking at like a half dozen lines of code. Very easy to figure out. Is what you do is you look at an element and you look at the element below and you go, oh, okay, do these need a swap? And I just constantly swap things until I got the smallest one up top, and then I look at the second item and I go through the whole list and I swap them back and forth, until I'm done at the end, and that's the second one. And I keep on doing this, and while it's very easy to write, it's very inefficient to run. There are much more efficient algorithms out there. The one we're going to look at is called a selection sort. And if you're going to look at it, you're going to go, this is almost the same thing. And in a lot of ways, it is. But the number of swaps that we do is much less. And that's what makes it a lot more efficient. So we're doing about the same number of tests, but the number of swaps we do is way down. There are going to be other types of sorting algorithms out there. merge sort, quick sort, heap sort. There's a bunch of different things out there you can look at, but they tend to be a little bit harder to understand and to therefore code. And especially since this is kind of an early on one, we want to focus on something that's really easy to work with. So selection sort is going to be faster than your bubble sorts. It's a more efficient algorithm. It's going to still be relatively easy. So let's work through this, and then we'll build it out so you can kind of see what goes on. Okay, so I have my function header up here. I take in my list and my list size, and remember, my list is just an array. Okay, in this case, it's an array of doubles. I have what my current minimum is and my current minimum index. Okay, and that's an important thing to keep track of. So I'm going to create a for loop, and I'm just going to go, okay, as far as the list size is, I'm going to set my current minimum index I. Okay, so my list element I, my index is I. That's where we start. Then we have an inner loop, and it says, okay, we're going to start with J. J is going to start at I, and we're going to go until we get to the list size. So it's that inner loop. This is where it's similar to the bubble sort. The difference is the bubble sort, I'm constantly swapping elements inside. And when I swap two elements, it's actually a three-step process. I got to take my minimum, my initial value, and copy that into like a temporary variable over here. Then I got to take the new value, put it back in my initial. Then I got to take my temporary and put it into the new value. And that may not be the only time I got to do a swap. I got to do a lot more swaps. So instead of doing all these swaps unnecessarily, the selection sort says, you know what, hold on. If my current minimum is bigger than my new index that I'm looking at, okay, so we're just checking that, then I'm just going to set my current minimum and the current minimum index. I'm updating those two values. So if I don't need to do a swap, I ignore it. If I do, I just set that value. I'm not swapping data back and forth. Okay, no data is changing. I'm just going to go through this whole process again and again and again and again. Okay, until I get to the end of my array. When I get to the end of my array, the end of this for loop, this inner for loop, I'm going to check and see, okay, does my current index equal what it originally was? Does my current minimum index equal what it was? If it does not, okay, if those values changed, then I'm going to set my swap. So at most I only do one swap. May do 0, at most 1. So I've still got test and test and test, but I'm only doing one swap. And this makes it a lot faster programmatically from our process when we build something out using a bubble sort. Okay, so it's still pretty easy to kind of follow and logically follow to see what it's doing, but it's still very easy to watch. Okay, so I'm going to take this, and if you have this inside of your own browser, you can copy and paste this in. Come down here. I'm going to make a quick change. This is a double. I'm going to set this to an int, since we're only going to work with integers at this point. And then I need to come up here and create my prototype. Okay, so copy and paste. It's our friend. Okay. Now that I've done that, I'm going to come over here, call my selection sort, pass in values, which is my array that I have here, and then my array size. Now, I want to make sure that this actually works. Is it just, magic, hocus pocus stuff? Who knows? So I'll copy and paste my little for loop here. And when I run this, if I scroll up, you'll notice that my elements are not in order. But when I get here, when I start over, you'll notice that all my elements are in order, just as I'd expect. And it happened very quickly. You didn't see any huge lag in time or anything. Um, Now, this is only 30 elements. So a 30 element array is not, like, oh, how long does it take for 30 elements? So let's just bump this up real quick. 3,000 elements, okay? Literally 100 times more. Let's run this. You see it printing out. You might go, well, how bad was it? Well, the answer was not bad at all. The key component was it takes more time to print to the screen than it does to sort. Okay, so printing to the screen is actually a pretty slow process. I/O is almost always a slow process compared to processing. So it still happened pretty quick. It was just a couple seconds, but most of that time was actually consumed in the printing to the screen. The other thing you might notice when you look at this is, well, wait a second, I've got a lot of duplicated values. The answer is yes, you do. And the reason why is because our initialization function only shows numbers between 0 and 999. Since we put 3,000 elements into our array, we know that there is going to be a lot of duplicates, okay? On average, you can expect 3 elements for every value. Now, if you look at this in reality, 994 only occurs once, but 993 occurs like 6 or 7 times. Okay, 995 occurs 3 times like you expect, but 992 and 997 occur only twice each. So it just kind of varies. On average, they should occur 3 times a piece. In reality, some are occurring only once or twice. Others are occurring 6 and 8 times, and that's just because of how averages work. That's nothing that we're not surprised by, for lack of a better term. If I didn't want to have duplicates or I wanted to reduce the chances of duplicates, I would go in and make a change and say something like, give me a random number between 1 and 30,000 or 50,000. Then my odds of getting a duplicated value become much, much smaller. So keep that in mind as well. Now that we have a sorted array, now we can do that binary search, and that binary search is real fast and efficient for finding a value. Binary search where we have duplicated values is even faster and easier in a lot of ways because you have more chances of hitting that match. Um, but with 30,000, binary search, you go in, if it's not one of those middle values, you cut off 15,000 elements right away. And then you cut off 7,000. Then you cut off another 3,000 or so. And before long, even that 30,000, you'll find that you're probably under somewhere between 17 and 18 tests to find that result, assuming that they were all completely unique. The more that you have the duplicated values, the faster you are to actually find it. So binary search works really, really efficiently. You just have to sort the data, and that's what your selection sort is for. Okay, so that's just a real quick example of using that selection sort. If you remember back to our previous class, you can see how we're modifying data inside of, we're modifying our array data inside of a function. So we get that data. We don't have to put it all inside our main. We're doing most of our work from function calls, which is great. What I probably want to do is I probably want to create an extra function. Since this has to be done twice, we want to probably, if you want to be efficient, you want to take this information, put that into a function. That way, just make it a function call. It keeps our logic simple, and that's always a good thing. Anytime that we have to repeat something, for example, here and here, we often want to ask ourselves, well, would this be better if it was just a function? Um, And so, kind of keep that in mind. But we looked at using arrays, we looked at using our functions, we looked at modifying array values inside of a function, everything that we did last class, things that we've done previously, all kind of coming together and gelling. One of the reasons I want to talk about that is just real quick, I want to go over, there is a assignment. It's working with arrays and functions. And the whole idea of this assignment is just getting us kind of used to what we've done. Last class, some of it with previous functions, thinking about how we use functions to optimize and be a little bit more efficient with how we move forward with our code. We'll just need some arrays. I'm recommending between 3 and 5 arrays, just so you have a chance to kind of send extra data to things. Okay, you will need to assign it some random values. Since you're going to have doubles and integers, you probably are going to want to overload that array initialization function. Hint, hint, just a little thing out there for you. From that, you are going to build a couple of functions. One that's going to calculate the average value of an array, and one that's going to calculate the total or the summation of that array, the array, and get that value. Okay. Once you've initialized your arrays, I want you to print them out, and they don't have to be sorted or anything like that. Don't worry about that. But you do need to print out your array, and you need to then display the calculated values for both your average and your total. Okay. Just a couple of hints. Remember, functions can call other functions. That's an important thing to note. I would not call anything from inside your initialization function. That I want separate, but when I'm displaying it, maybe that's when you want to call that average and that summation functions. Okay. I also would recommend that if your array values do not need to change, using that const keyword so that they don't accidentally get modified. That's just a good programming practice. So look at that. And if you need to spend a little bit of time beforehand organizing and practicing with your project to get it set up. Once you do that, you should be good. Actually, should not take very long to write, especially if you go through some of the examples in the book, or if you don't, I've got some examples online that will help you work directly through this. So if you have any questions on it, of course, please feel free to email me. You got a whole week to work on this. But this is just a good practice to kind of be working with your arrays, using constants to set array sizes, functions and passing array values to your functions, and doing some other stuff. So hopefully I know arrays are sometimes people feel like this a little nebulous, a little weird. This should give you some good hands-on practice and help solidify this concept and make it really, really obvious for you and make it a lot easier going forward. So that's the whole purpose of that. Like I said, if you have email or have questions, you can feel free to email me or attend during our the virtual office hours that I have set up, and we can set up on Zoom and we can walk you through where you might be stuck and stuff. So just want to give you a little heads up about that got posted today. Okay, let's come back here. And the last thing we want to talk about today, just the last little bit, is something that part of this is historical reason for covering this. And this is what we call a C-style string. And I've mentioned these before. And how we used to have to do strings. Now there is obviously a string data type, and that is great. It is very helpful, very useful. I love it. But knowing about C strings is important for more reasons than just historical reasons. You do see them out there periodically, and the reason why is they're very, very fast and efficient to create and use. So I want to give you a little bit of info so you can run into them. The other thing I want to specify is anytime you use a string literal, So if you're putting in a string literal into like a cout function or something like that, you're actually using a C style string. Okay. So what is a C style string? Well, a C style string was actually just an array of characters. And the problem was you could have two different types of arrays of characters. One was you could have an array like this. Okay, so you notice I say char city 1, and inside of double quotes I put Greenville. Okay, and as a city name, that is a C string. It's an array of characters. Don't get me wrong, but it was treated as one element. What was interesting is as while you see Greenville here, there was one more character right here that you don't see at the end of that closing quote, and that was what they called a null character. Null character is ASCII character 0. You'll sometimes see it written as \0, and it was used to terminate or end, if you would, a C string. Okay, and you had to have that null character, and there were some special built-in functions, and they looked for that null character. If you did not have that null character there, it would just keep on reading in memory, and that got a little dangerous. So we had to always be careful of that, but it did work. Now the second type of array of characters would be something kind of like this, and that was just an array of characters. It was not a string. It was just an array of characters. You could not treat it as a string. So it did not have that null character, and that was the biggest difference, and it caused some issues. Um, so we're going to look at what happens when you put it inside the double quotes instead of a collection of letters and individual single quotes. Okay. So there's a couple ways that you can do this. I create an array here. I print out my data. Boom. Okay. And that worked. It was real simple. In the old C style, there was actually a command called printf. There was a couple different input output functions like that were used, and they knew how to look for much like cout looks for different data types. The printf, we had to kind of tell it what type of data it was, but we could print out that information. If we want to use input, we would use something like cin.getLine, and that works. Remember though, because of how we work, we want to make sure our array is big enough to accept that value. If someone says, steak, oh, that fits in. But if someone says, my favorite food is chocolate ice cream, that's not going to fit in 16 characters, not even close. I'd have to be careful, because if they wrote something that was 16 characters, I would have an issue because I don't have that null terminator at the end. I always have to have that null terminator off at the end. So that's part of the reason why we don't use them a lot, even though they're more efficient. You gotta be really, really careful of them. If you're not, it causes issues. Okay. I did mention that there were some special built-in functions to work with them, because you couldn't just assign a value like this. Okay. If I did this, I'd get an error. Okay. In fact, let's just kind of show you what would happen. Okay. So if I come into my screen and I show you in Visual Studio, I said this is a sample string, and they go, oh, data, another string. Notice that it underlines data for me. If I look at it, expression must be a modifiable L value. Okay. I think we saw this error last class, the L values. It's where we actually store the information. We have an L value and R value. The L value is where we actually store the information. You can't just assign a value to an array. So you saw how we use that cin.getLine. Okay, that's one way if we're getting data from an input. If we're getting data from someplace else, we need to assign a value like this, where it's a hard-coded value, or maybe we pull in a value from some other source. We're duplicating another string as an example. Then what we can do is there's a string copy. Okay, there's actually two different string copies. There's a string copy in a strn CPY and a strcpy. Okay, now if I use strcpy, I'm going to show you, Visual Studio is going to throw an actual error. It's a legitimate function, and I'm going to show you why Visual Studio throws this error. It's a really neat thing in some ways. Okay, so let's comment this out. We don't need that. Okay, so I'm going to say string copy, and I'm going to copy to my destination first, so data, and then my source, another string. Okay, and I put my semicolon there, and things look good, and then I'm going to go and do a build real quick. And when I build, you'll notice that down here at the bottom, it comes up and it gives an error. Now, this is not technically an error, but it is. And this is a really interesting thing that Visual Studio is doing for us. And so there's a reason I want to point it out. Okay. This is a deprecated function, which means that it's a function we shouldn't use. And the reason why is it's considered unsafe. It's a memory unsafe function. And that is, I can copy data into it that's bigger than what my data size is going to be. Okay, I can copy more data than what's going to fit into data. So data, if I look at this, I got 4, 5, 7, 8, 9, 10, 25. Oh, look, 25 characters. I can now have to count. Just hover over and it shows me. Okay, 25 characters. If I come in here and say another string of an even larger size, data is 25 characters. I'm trying to put 39 characters into it. String copy will let me do that. Problem is, I've got an assigned set of data in memory. And over here is where that data variable is. What's after it? I don't know. But I'm going to put data on top of it. I'm going to overwrite that data. And now my application is just going to blow up and die. Okay? That's a real problem. Okay, that's an unsafe when you talk about, and sometimes you'll talk about and hear people talking about memory unsafe functions. This is kind of one of the things that they're talking about. They're saying, whoa, we can just bypass our data, blow right past it, and put code into other things. Now, with more recent versions of our operating systems, our data applications tend to be a lot more protected, which is really good. We run in isolated memory spaces. Older machines did not have that. That takes extra processing power to handle and stuff. The older OSs, you could literally overwrite another application's data. What does that mean? That means the application is going to crash. Maybe not the one that you're working in. Someone else's application is going to crash. That's really bad. You could really mess up other applications' work, and that was never a good thing. And that's the reason why strcpy is marked as being unsafe. Okay, because this is how security holes can actually be opened up. Is, well, what happens if I intentionally do this, and what I copy into it is executable code that I then go in and run as a virus. That's real bad. Okay, so minor bad is I crash an application or maybe the whole system. Really bad is I've now inserted a virus into memory space that looks like data, but I can run it. And how not good is that? That's all types of not good. there's other things that can happen with unsafe memory uh, functions. And that was a problem with C early on. Um, because of the speed of computers and what was going on, you were kind of limited. Um, now we can do better. And so what this does, if you look at this whole message, is it says, okay, you can flag, and we're going to let you, we're going to assume that you, the programmer, are smart and know what you're doing and everything's okay. Or here's another function you can use instead. And it's going to be a little bit more cautious about it. And it's going to figure out how to fix it. Now, if I come over here and build this, it's allowing it, but it's either going to move, it's either going to truncate what I'm copying into it, and or it might go in and move me to a different data point. So my memory location changes so I don't trash other people's data. How it's going to handle this is going to be behind the scenes, and I don't have to worry about this too much. All I have to worry about is the fact that now my data is safe and I'm using the right function. I do put a note of this inside of the actual notes. Okay, this is a Visual Studio thing. Okay, other things that you can go through, there's a string compare. 0 is if they're equal, -1 is if string 1 is larger, positive value, string 2 is larger. And then if I've ever wanted to convert strings to numbers or numbers to strings, I have A to I, which is an array, a character array, to integer, or to floating point, or to long. So you notice I've got some different functions. You might say, well, why aren't I using the same things, string to number? Old C did not allow for function overloading. So I had to create a new function for every new data type that I might pass into it or convert out of it. Ay, ay, ay. Mess. Total mess. This much, much easier. Okay. Um, Same thing if I want to do I to A, integer to array. Okay. So I've got a couple different values I can try and look at there. We have some others that you can look at. So those are some things. Like I said, we're not going to be using this too much. It's not as important as it used to be. We're going to focus on using the strings inside of our C++. They're a lot easier to work with. We don't have to worry about some of these kind of weird archaic functions. And that's a real good thing. All right. That's about everything for today that I wanted to cover. Real quick before we disembark, are there any questions that you guys have? Anything you need to see or anything like that before we go? Don't forget you're on mute, so if you want to say something, you have to unmute your line. Okay. If not, thank you all for coming. I do appreciate it. I know it's different moving online and whatnot, but I really do appreciate you taking the time to do that. If you have any questions, do feel free to email me or come to the virtual office hours that are set up. I'd be more than happy to help you out with anything that I can. If you have questions, you're just not sure, we did get information on registration for fall term and how that'll be happening. So even though I can't register for you, I can kind of point you in the right direction. That as well as graduation. I know a couple of you guys are seniors. Otherwise, have a great weekend. Don't forget the assignment. If you have questions about that, reach out for me there too. And I will talk to you all later. I'll stick around just for a couple minutes in case you do have questions, but we only got about 2 minutes left before we get kicked out from our 40-minute time limit. So, but I will stick around if you guys need it.